Okay, this is a quick video that's going to help you walk you through NCEA Science 1.1 mechanics. This is the first in the series, and we're going to start with a little introduction into forces. Okay, so if we're starting with forces, we should probably start with what a force is. So force is essentially just, we've got the definition coming up here, force is a push or a pull that changes the motion of an object, or a squeeze or a twist that changes its shape. So a few words there, common words we use every day. If we use the word push, pull, squeeze, twist, we're talking about a force. And a force will either make an object change its motion, so it could cause it to speed up or slow down, or change direction, or it could change its shape. Now the size of a force is always measured in this unit. In these units we call newtons. So whenever we write down a force, we always use at the end of it, so if we say force might be 40 newtons. This is just like when we measure distance, we use centimeters or meters or kilometers. Newtons is the unit we use to describe the size of the force. So types of forces. So you may have in class covered a few different types of forces. Now some books and things use slightly different terms than others. I've got a little list under here. Those pictures aren't entirely complete. So here we go. Contact forces. These are forces that require a direct contact between the object or person applying the force. And non-contact forces. So this is where a force is applied without any direct contact between the two objects. So contact forces, we've got applied force. So this is literally when one object or a person applies a force directly to another object. The thrust force, so this is a force that propels an object by pushing against air or water. So this is the kind of force that would be pushing a boat or a plane through the air or through the water. Support force is the upward force that's exerted by a surface in order to support its weight. So you'll see over here we've got gravitational force. Well, support force is the one that actually always opposes our gravitational force. If you look at any object sitting on your desk right now, or even look at yourself, the force of gravity is trying to push you down into the ground, and the support force is essentially the floor or the ground pushing back, and that's what's stopping you from actually sinking into the ground. So we've got friction as a force that always opposes the motion of two objects when one is sliding over the other. And we have drag, which is just essentially a type of friction, and again it resists the motion, so it's always in the opposite direction to the direction the object is moving, and it resists the motion of an object through a fluid, such as air or water. So drag is sometimes also called air resistance. If you're moving through air, you'll experience air resistance, or through water, you'll also experience drag. Tension force. So a tension force is a pull force that's associated with the stretching of an object. So if you're having a tug of war, the rope will be under tension, it will be pulling back. Or if you hang something on a rope, you've got the gravitational force pulling it down, and the tension in the rope, the tension force pulling it back up. And that's what's resisting the gravitational force. So any object that's being stretched will be experiencing a tension force. Our non-contact forces, so we mentioned gravitational, that's the force due to gravity. We also call that weight. So your weight is the force due to gravity, and we'll talk more about that in one of the next videos. We've also got magnetic force, so that's a force due to a magnetic field. So think of two magnets. You can push one magnet along using another magnet, and you can do that without any direct contact, so magnetic force. And electrostatic force is the force due to that occurs when you have two electrical charges. So you've probably played around with charging up a balloon against your hair. Well, the balloon and your hair get oppositely charged, and there's that force of attraction between them. And if two objects are charged equally or have a like charge, they're both positive or both negative, they'll actually repel each other. So charged objects can exert a force on each other, and again they don't actually have to be in direct contact. So it's electrostatic force is a non-contact force. Now occasionally you will get other types of forces. For instance, up here you'll get other terms. You'll notice we've got spring force in this picture, also sometimes called a compression force. That's essentially when an object is squashed think of squashing a spring, it pushes back. Or here, buoyant force is sometimes used for an object that's floating. So you could look at a boat floating in the water. The buoyant force is what's going to be pushing it up or resisting that force of gravity and stopping it from sinking. Or a hot air balloon, if it's floating in the air or even rising, it'll be the buoyant force is that upward force that again is resisting the force due to gravity. So there may even be another couple that I haven't referred to here. Different books sometimes use slightly different terms. If you're doing a curriculum other than NCEA, you might want to check what terms they use. But essentially, usually it's fairly easy to figure out, in which direction the force is actually acting. Which takes me kind of to my next point. You'll often come across these, and you'll probably have to even draw one of these when it comes exam time. We use these things called force diagrams. Now, force diagrams really aren't anything too scary. We basically take the object and we're just labeling the forces and the direction in which they're being applied. So if you look at my car here, we've got the applied force, or sometimes you'd even put thrust potentially, but we've got a force that's generated by the engine pushing the car forward. We've got friction or drag, a force pushing backward. The weight force, so that's the force due to gravity, is pushing down. The support force is the road pushing back up on the car, stopping it from sinking into the ground. So a few things here that are just conventions. You'll notice we tend to draw the arrows from the center of the object, pointing outward. And secondly, the really important thing with these force diagrams is what we're trying to use these arrows to show is actually the size and direction of the force. So you can see the direction here, but the size is also important. So for instance, if the car, the weight force, the force due to gravity pushing it downward, and the support force, the road pushing upward, need to be equal. Otherwise, if the weight force was greater, it would be sinking down into the road. So we use the arrows to show kind of the relative sizes of the forces. Over here with my plane, we've got some of the forces. Weight force again, thrust force is the force pushing it forward, drag, that force resisting the direction of motion, so you can see it's in the opposite direction to which the plane is moving, and the upward one, this is also often called lift. So there you go, another term. So as a plane moves through the air, it generates an upward force called lift. So that probably should technically even say lift there. So the key thing here is just to realize that those arrows show the size and direction of the force. We're going to use a few examples of these in our next video when we look at this in a little bit more detail. But that's it for now.